Hi, sixth grade. Hopefully, everybody's doing well and had a great night. Well, we're going to get started on a new lesson. That's Chapter 10, Lesson 8, Probability of Compound Events. So let's figure out where those notes are with that. So go up here to Classroom, go down here to Chapter 10, go down here to Completed Notes. We are right here, Chapter 10, Lesson 8, Student Completed Notes. So let's pull that up there. Now, if you look on this printout here, you can see, especially as we get down here onto the second page, some of these spinners are hard to read. So if you open up your books, also they are in your book on page 484 when we get down here. I'll remind you as we get closer to those ones. So let's look up here. Okay, we're dealing with compound events. Compound events means, hey, we are multiplying our events together, which means a compound event consists of two or more simple events. The probability of a compound event is the fraction of outcomes in the sample space for which the compound event occurs. When you work with compound events, you can make a table or draw a tree diagram. I'll also show you an easier way also, or make a list to display and count all the outcomes in the sample space. So let's see what we're talking about here. So we're dealing with compounds, so we're dealing with more than one event here. So let's take a look here. Example 1. It says a pet store sells aquariums in 3 shapes: hexagons, pentagons, and rectangles, in 2 sizes, 10 gallons and 20 gallons. How many different fish tanks can be made from the 2 different shapes and the sizes? So this is what we mean by a compound event, because here I'm dealing with the shapes and also dealing with the sizes here. So that's why they are compound. Now, one of the easiest ways to solve these ones are just to multiply. I have 3 shapes times 2 sizes, which means I'm going to get 6 different tanks here. So if I take a look here, if we do it as a tree diagram here, so I have a hexagonal tank. I can either get the hexagonal tank in a 10-gallon size or a 20-gallon size. I can get a pentagonal tank in either the 10-gallon size or the 20-gallon size, or a rectangular tank in the 10-gallon size and the 20-gallon size. So as you see right down here, here are all of our outcomes. I have the hexagon 10-gallon, hexagon 20-gallon, pentagon 10-gallon, pentagon 20-gallon, rectangle 10-gallon, rectangle 20-gallon, which gives me 1, 2, 3, 4, 5, 6 different tanks here. So I have 6 different tanks here. Over in this one, it says a greeting card maker offers 3 birthday greetings in 4 possible colors, as shown below. How many different cards can be made from 3 greeting choices and 4 colors? Well, Mr. Spencer's already made a mistake here. If you take a look here, we only have 3 greetings. 1, 2, 3. He accidentally put 4. So please correct that mistake and make that a number 3. So we have 3 greetings here, and we have 1, 2, 3, 4 different colors. So 4 colors here. 3 times 4 is 12. So we're going to have 12 different types of cards to choose from. So if we make a tree diagram from this one, okay, we have our humorous cards that can either be in blue, green, orange, or red. Then we have our traditional cards, which can be in blue, green, orange, or red. And then finally, we have our romantic. We have our blue, our green, our orange, our red cards, and here are all of our results down here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So we have 12 different cards that we can choose from here. Okay, let's continue. Let's see what else we have. I think we're going to make some tables here now, especially with this one here. It says students are assigned a temporary password the first time they visit the computer lab. Temporary passwords consist of a letter, either A, B, or C, followed by a number, 1 or 2, followed by a letter, either X, Y, or Z. So how many different temporary passwords are there? Okay, so we're going to start with 3 letters, your A, B, or C, then followed by 2 numbers, and then finally followed by 3 letters here, which is your X, Y, and Z. So if I go 3 times 2 is 6, times 3 is 18 different passwords. Well, let's figure out what these passwords can be. So if we start with A, B, C, then we'll go A1X, B1X, C1X. Okay, let's go with A, B, C again. 1, 1, 1, but now we got our Y. So A1Y, B1Y, C1Y. And then let's go with our Z's at the very end. So A, B, C, 1, 1, 1, and then all Z. So A1Z, B1Z, C1Z. Okay, now let's go with our center numbers as 2s. Okay, so it's going to be ABC, 2, 2, 2, XXX. So A2X, B2X, C2X. Okay, we're going to do Y's at the very end now. So ABC, 2, 2, 2, YYY, A2Y, B2Y, C2Y, and then finally we got our last one here with the Z's. So ABC, 2, 2, 2, Z, Z, Z. So we got A2Z, B2Z, and 3-2Z. So we have 18 different passwords we have here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So 18 different passwords there. Okay. Let's look at some elections at the student government. So the student government consists of a president, a vice president, and a treasurer. Okay. The candidates for president are Jackson, Juan, and Megan. The candidates for vice president are Jacques and Carlos, and the candidates for treasurer are Lee, Jacob, and Carl. So how many ways are there to choose a president, vice president, and a treasurer? Okay, so we look here, we see, hey, for the president, we have 1, 2, 3 people for president. So there's our 3 there. How many people are we going for vice president? 1 and 2. So just 2 going in for the vice president. How many people are trying to go for the treasurer? We got 1, 2, 3. So we got 3 for treasurer. We multiply these together. 3 times 2 times 3. So 3 times 2 is 6. 6 times 3 is 18. We got 18 ways in which we can choose a president, vice president, and a treasurer. Okay, let's look and see what else we have here. On to the next page. We're dealing with the probability now. So we're dealing with a fraction. Okay. When you know the number of outcomes, well, that's we just figured out how to figure out those outcomes. You can find the probability that a compound event will occur. When you work with compound events, you can use the fundamental counting principle to find the number of outcomes. Hey guys, guess what this is up here? This here, when we are multiplying, is known as the fundamental counting principle. So that's one way to do that there. Okay, so it says, the fundamental counting principle, it says if event M can occur in M ways and is followed by event N that can occur in N ways, then the event M followed by N can occur in M times N ways. Guys, that's just what we did up here. That's all we did up here. Hey, we said, hey, 3 people for the president, 2 people for vice, 3 people for the treasurer, multiply them together. That gave us our 18 ways. Okay, so there's an example there if you'd like to read that about the fish tank. That's what we did up top. Okay, let's talk right now about a good old Emilio. Emilio has 2 counters. Each counter has one side marked as E and the other side marked with J for Jacob. Both counters are tossed. If counters land with E up and the other lands J up, Emilio wins. Otherwise, Jacob wins. What is the probability that Emilio wins? So let's look at these outcomes here. We could have a flip come up to be an E and an E. We could have a flip come up to be an E and a J and an E, or a J and a J. So we have a total of 4 outcomes here. So we know if Emilio wins, it must come up either as EJ or JE. So there's 2 outcomes there. If Jacob wins, it has to come up as EE or JJ. But we're looking at the probability that Emilio wins. Well, we know there's a total of 4 outcomes here. So that's why the 4 is in the denominator. So the probability that Emilio wins, there are 2 outcomes that will cause Emilio to win. So that's why we do our 2 over 4, which is equal to 1/2, which is the same as 50%. So the probability that Emilio wins is 50%. Well, let's look over here. It says a toy robot moves straight ahead until it hits an obstacle. Then it turns with equal chances of turning left or right. If the robot makes 3 turns, what's the probability that all 3 will be left turns? Okay, so let's look here. Okay, so the robot could go left, 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 right, left, right, 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 left, right, left, left, right, left, right, 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 left, and right, left, left. Okay. So basically, the fundamental counting basically would mean, hey, its first turn, it has 2 choices. Its second turn has 2 choices, either left or right. The third time it does this, it has 2 more choices, left or right. So there's my 2 there. So that's how I get 8 of my outcomes there. Now we want to know the probability it will make 2 left turns. Well, if we look here at all the different choices, there's only 1 here where it makes 2 left turns. So that's why it's 1 over 8. And if I were to do that as a percent, so 1 divided by 8 would give me 12.5%. So if you want to write that down there as 12.5%. The actual answer was 0.125. But remember, if I'm making that into a percent, I have to move the decimal 2 places to the right, which gives me my 12.5%. Okay, let's continue on here to the last 2. Okay, if these are very, very hard to see, they're actually in your book on page 484, example 4. So what it says here is Lamar is going to spin each spinner once. What's the probability he will spin red and the number 9? Well, basically, let me show you here. This one here, this triangle here is an R for red. This one here is a B for blue. This one here is an O for orange. This one here is a P for purple. And this one here is a G for green. Okay. And these here you can pretty much see. This is number 1, and this is number 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Well, let's figure out what the total number of outcomes are going to be. Well, I have 5 outcomes here with my colors, and I have 10 outcomes here with my numbers. So 5 times 10 is 50. So I have a total of 50 outcomes possible here. Well, we want to know what the probability of getting a red and a 9 is. So there's only 1 red here and 1 number 9. So R and R9 is only 1 chance. So it's 1 over 50, which is equal to 0.02, which is the same as 2%. Okay, let's go on to the next one here. Last one here. Henry Henry rolls a number cube and tosses a coin. What's the probability that he will roll a 3 and toss a heads? Okay, so using our fundamental counting principle on our number cube, which is a die, there are 6 possibilities, numbers 1 through 6. Okay, on a coin, there's either heads or tails, so there's only 2 outcomes there. So fundamental counting principle, 6 times 2 equals 12. So there's a total of 12 outcomes here. And we want to know what's the probability of getting a 3 and an H. Okay, well, guess what? There's only 1. So 1 over 12 is the probability. And if we were to divide that out, 1 divided by 12 is going to be 0.8333333. So if I move the decimal 2 places to the right, this gives me 8 1/3%. Okay, guys, I hope you understood everything on compound events. If you're uncertain how it works, please rewatch the video again. If you have any questions, please email me your questions. Other than that, guys, tomorrow is going to be a catch-up day. Make sure you have all of your homework done. Organize your notes. Get your homeworks all together also, because we're going to be starting the test here very soon. Other than that, guys, take care, have fun, and talk to you soon. Bye-bye.